Why is the double-slit experiment conducted with photons or electrons and not with macroscopic objects like basketballs? Or why do we, when passing through two doors in front of us, not exhibit wave-like properties? Is the scientific world hiding something from us? To date, we have witnessed the double-slit experiment being conducted mostly at the atomic level, specifically with particles as large as 2,000 atoms. At the 2,000 atom level, unobserved particles continue to behave like waves, while observed quantum objects continue to behave like particles. So, why isn't this experiment conducted with larger entities? Let's go even bigger. If a test were conducted where basketballs were thrown at the slits, what would be the outcome? Nobel laureate physicist Tayna Mahut and her team wanted to test this concept using basketballs to examine the relationship between consciousness and quantum mechanics. It should be noted that this experiment was deemed unethical by the scientific community, as it was seen as an attempt to win a double Nobel Prize. At Bhutan University, standard basketballs were thrown into double-slit tunnels with specially designed equipment. The experiment showed that, regardless of whether they were observed, the basketballs exhibited particle properties every time and never displayed wave-like behavior. Let's set aside Tayna Mahut's experiment and return to reality. If the double-slit experiment were conducted with macroscopic objects, such as basketballs, it would almost certainly adhere to the rules of classical physics. In short, if you run toward two doors, you would only pass through one of them. The wave-particle duality observed in microscopic objects, like subatomic particles, disappears at the macroscopic scale. When you attempt to pass large objects, such as basketballs or other macroscopic items, through a double slit, quantum mechanical behaviors like wave interference or the formation of interference patterns are not observed. This is because the wavelengths of such macroscopic entities are extremely small and negligible. Hence, they exhibit classical particle behavior. The experiment does not work at the macroscopic level, and the results align with the expected classical physics rules. The reason for this is that the wavelengths of macroscopic objects are much smaller than those of microscopic objects. The wavelength of macroscopic objects is very small due to their large mass. To explain this, we use the de Broglie wavelength formula. According to this formula, the wavelength of an electron is calculated to be approximately 7.27 x 10 to 10. When we calculate the wavelength of a 1-gram basketball, the value we obtain is approximately 7.36 x 10 to 34. Comparing these two values shows that the electron's wavelength is about 9.88 by 1023 times greater than that of a human. This is precisely why quantum properties of macroscopic objects are so insignificant. Perhaps basketballs also exhibit wave-like properties when unobserved, but their wavelengths are so incredibly small that they cannot be measured. See you in our next video. If you subscribe to our channel, like our videos, and leave a comment, you'll be giving us great support.